Okay, so we're going to move on to a new section. And actually, I mentioned Kevin was actually part of the Living Heart Project as an intern, so was Hao. One of the things that we've really enjoyed as part of building this community is helping to generate the researchers and the future leaders in our field. And we saw some examples of that just a few moments ago. This next section is really going to talk about a very special relationship that we've started, a center of excellence with Long Island University. And let me just flip to that. And we have representatives here from Long Island University who are going to talk about this Center of Excellence for bringing this research, this understanding of a new way of teaching students and actually implementing it into the educational system. And so I have representatives here. I'd like to invite Dr. Mohammed Cherkaoui to the stage. He's the provost in charge and the visionary behind this revolutionary center. So with that, I'd like to invite Dr. Cherkaoui to the stage.
Thank you. So before I give the stage to Dr. Nicolas Gallo, who will basically cover all the research emphasis that we develop in Dassault Systèmes Center of Excellence in New York. I think it's the first center of excellence in life science that received the label of Dassault Systèmes. So it was really a privilege for us to be in this endeavor with Dassault Systèmes. So I will not cover any science now. So I will let I will let Dr. Gallo to give you more details. I am the provost and vice president of research at Long Island University. I've been at Georgia Tech for more than 20 years, and I know Dassault Systèmes by heart because basically I work directly and indirectly with Dassault Systèmes since 2001. So in 2003, we were pioneering to introduce the Dassault Systèmes technology and especially CATIA in our curricula at the School of Aerospace Engineering at Georgia Tech. And I think all you guys today, you know Dassault Systèmes in terms of industry, in terms of manufacturing, in terms of the impact for research, but we don't know Dassault Systèmes in terms of pedagogy, the impact on education, initial educations, and so on and so forth. And basically, at Long Island University, we raised this challenge back in 2018. So we were the first to deploy the what we call the 3D experience. So the first of its kind at the State of New York. So here you can see the street, the main avenue in Brooklyn with the 3DS experience in Brooklyn, when a main emphasis is made on the workforce training. And basically, we were able, thanks to Dassault Systèmes, to build the first School of Digital Engineering. And I will explain what does mean digital engineering. If you can please go to the next slide. So this is how it looks like, the platform of the 3D experience in Brooklyn. You know, this is basically, we hosted students with the diverse experience and the diverse expertise for what we call an immersive learning experience, what we call dendritic experience. We were able, I will give you 3 different examples that we basically follow to pave the way to education and outstanding education. So first of all, today we don't talk anymore about engineering. No mechanical engineering or electrical engineering or material science engineering. We are talking about the new engineering of the 22nd century. And this engineer has to fulfill many hard skills, ranging from materials to mechanical to electrical and so on. So we were basically to start to be pioneering, to initiate the first engineering program that we call digital engineering, which is in essence multidisciplinary, which is cross-linked in many disciplines. And it took us 4 years to work back to back with NICED. NICED is a New York education system for accreditation body, but also to work with IBET. So IBET is the accreditation board of engineering and technology to be able to receive or to evaluate this new program, because they was totally lost where to put this program. Is it mechanical? Is it electrical? Because as you may know, engineering programs are very, very conservative, okay? So now, today, I can announce you that we received the IBET accreditation after 4 years, negotiation. So the program will start this fall, and this program rely 100% on Dassault system enabling technologies, okay, for immersive education. So this is the first example I would like to highlight. The second example, under my supervision, I have the College of Pharmacy, which is the largest college of pharmacy in the United States. It's the oldest one. And we did a kind of evaluation back in 2019. And we ended up with one report that stated the following. What we call the retail pharmacists who work for CVS will disappear in 5 or 10 years. Pessimistic case, they said 5 years, optimistic 10 years, because basically we will experience a physician will just prescribe a molecule. The molecule will be sent to a remote platform for additive manufacturing for drugs, and then the drug will be shipped to the patient directly. So all these companies such as CVS, they are working on new paradigm shift. So today in my College of Pharmacy, we are working with BioVia to implement courses in silico drug design in our curricula and make this kind of paradigm shift in the way to train the next generation of pharmacists. And today we call them the pharmaceutical engineering, okay? And this is a new paradigm in pharmacies. Today, I was very impressed, and I will finish with this. I saw many physicians, how comfortable they are to share with us some technical discussion in terms of mechanical properties. I saw physicians explaining what is the stiffness of a materials, how you increase the stiffness, and how you can. So this is a new paradigm for me, the way to train the next generation of physicians, okay? And today I can share with you many, many universities, and especially the MD schools, they are doing this kind of reforms, to train what we call the MD engineer. They call it today the physicianeer, basically. So it is happening today. MIT jointly with Harvard, they are working together to implement this new model for the next generation of MD. We are working also with the Baylor College of Medicine to pave the way. So basically, Long Island University will cover the pre-med using digital tools and so on, and also other experiences. So I would like just to finish with this, in terms of education, the workforce training, and all the technologies. And I would like to give the stage to Nicolas.
Thank you. Thank you, Mohammed. So with a little bit of time that I have left, I will talk to you about the scientific projects and innovation that our students will be exposed from day one. I will skip that. We covered everything on the digital engineering approach. So really the Center of Excellence that was founded by Mohammed Cherkaoui and all his team past couple of years is a center where multiple disciplinary connect. We have pharmacy, veterinary medicine. We have obviously Dassault Systèmes, the pillar of this endeavor, and clinical expertise for the Baylor College of Medicine, and also pharmaceutical company, to make sure that the students are exposed to these projects from day one and work on industry and clinically relevant projects. So everything falls under what we saw this morning from Patrick Johnson, the Dassault System virtual human environment. And really motivated by we've seen a lot of clinical, more medical device and surgical applications. What we're trying to start, and we made the announcement last December, is to work on the liver and tackle issues like hepatotoxicity in drug developments. So you can see the data from the NIH that liver toxicity is the second cause of failure in the post-market evaluation stage. So it is also similar to the slide we're very familiar from Steve on the heart. The liver is a multidisciplinary, multi-scale problem. You have the organ scale of the liver, about 30 to 50 centimeter. You go down in scale in the functional unit. You're looking at the lobule that is 1.5 millimeter, and then you go down to the hepatocytes, stellate cells, and all the cellular level. So really, the goal of these projects that we initiated in December is to evaluate drug-induced liver toxicity for pre- and post-market evaluation. And we find, again, this schematic that everyone here is familiar, the multi-scale aspect, starting from a drug interaction with the protein, the cell. How does that reflect in the cellular function? How does the cellular function affect the function of functional units? And all the way up to the tissue, to the organ, to setting up the simulation of the problem we're trying to solve, to parameterize these models to create virtual cohorts of patients. So we made some progress. We started very recently, but we made some progress at the cellular scale, looking at drug metabolism, looking at cellular mechanism and injury, thanks to our partner at Baylor that really understand the intricate mechanism that happen at that scale. Most of the work for us engineers to model has to happen at a functional scale. This is where we're focusing most of our time right now. And we also have an engineer working on rebuilding from medical imaging data the macroscopic liver to tackle surgery planning procedure. So this is a work that we're doing in collaboration with the National Hospital Hospital in Singapore. We got the data kindly provided by Dr. Gayutia, and our developers at the Center of Excellence are rebuilding the macroscopic liver and the vasculature. So that work is ongoing. So very early results, obviously, for today on the liver. Similarly, the same team of developers have made good progress in developing, in capturing the physics, the fluidics that happens at the lobule scale. Because why is that important? Because that physical model that captures all the material science and the fluid mechanics of the lobule will then become the platform on which all the pharmacogenomics and the pharmacokinetics will be embedded into. So that's the stage where we are at. So now we are actively seeking collaborators with a strong expertise in biochemistry to help us push this model to looking at how the drug interaction with hepatocytes affects the performance of the liver. So if the liver was the second cause of failure in post-market evaluation, the first one is cardiovascular. And this is actually work that was inspired when the first time I joined this symposium in 2019 by the work of Dr. Helen Cole in Stanford and Matthias Perlink now in Delft University. So a pharmacy student that had no background in computational science, she was fluent in Word, Excel, and Microsoft suites, but never used any kind of modeling tool, is now working on reconstructing the geometry of ion channel, the beta channel in cardiomyocytes. And she's focusing, her expertise in pharmacogenetics, so she really focuses on capturing how different expression of phenotypes in different people changes the geometry of these channels and affects how the drug interacts with this channel. So thank you very much for your attention. So everything happened today thanks to the leadership of Mohammed Cherkaoui and the help of all these amazing co-workers. And so, as you've seen, the liver is very early stage. We just defined the problem and starting collecting the initial results. So we have assistant professor and postdoctoral position open at the Center of Excellence to work on these projects. Thank you very much.
Okay.
Thank you.
Thanks. So, no, don't leave.
Oh, okay.
You moved so quickly, you left time for questions. So, which is appreciated. Nope, we're okay. We'll catch up. So, as Nicolas discussed, hopefully you appreciate, as Mohammed described, this is really a stake in the ground towards the future. You know, getting the first digital engineering program approved in the country is a major achievement that I think will send waves throughout the community. We're living that. You know, you've seen through the Living Hard project, our premise was to create a template and go very deep and see how far. We heard this morning how far we were able to get. Now we're starting to go wide. So we're seeing Nico's team starting in December.
Oh, decided in February.
Yeah, in February. And there's now a multidisciplinary community all running around the world, experts from all various sides, all working and accelerating something that's never been done before, and that's the liver model. And so that's the power of what we're really doing, is getting that transformation. So with that, let me open the stage to any questions that you might have for Nico or Mohammed. We have one here.
Thanks for the presentation. So, as you're early in building your living liver, I was wondering if you can share with us what are the major challenges and how you are thinking of addressing them.
The major challenges that, I mean, this community is very well versed because you had to rebuild the heart is a lot of the specialties that focus on hepatic problems work in silos and don't necessarily talk to each other. So when we focus on the macro scale, there's a lot of literature from the radiology and the liver transplant surgeons. When you look at the metabolism, it's mostly from the biochemists. And if you look at the Swiss scale, I talked to you about the functional scale, and funny enough, this is where modeling is the least advanced, because that's a scale you need to integrate what happened to the cellular scales to the macro scale. So from the engineering perspective, the lobule is really challenging.
Another question? In the back.
Yeah, hi. This is really exciting work, and I know it's in the early stages, but I guess one of the biggest challenges when it comes to modeling in liver, especially the drug, is building predictive models. Essentially, let's say a white powder, which is a new drug in the market. It's very difficult to predict how much of the drug will get metabolized, and I guess even more challenging to predict, which is a PK, and then even more challenging how the drug will act, which is the PD aspect. So I was just wondering if there is a roadmap or a plan to build predictive models of drug metabolism and drug pharmacodynamics based on AI, ML, or data-driven, or any other such models.
No, that's a very good point. We're just very lucky that Steve and his collaborators, we built the hearts, and they have, you know, a couple of years, 2 or 3 years ago, shown the very interesting results for hepatotoxicity. So what they did, they validated the model with drugs that were already proven to be hepatotoxic and taken out of the market. So we're going to follow a similar approach, finding drugs that we know are toxic to the hepatocytes, and we understand the mechanism of action to validate the model.
Great. So I think I will have to probably cut it off at this point, but thank you again.
Thank you very much.
And thank everybody.